Now we're here at the command station. We've got gears up on the video all behind us, and it's time for us to take a look at translations or the linear movements. You know, and if you recall back to when we were introducing 3D motion capture, my experience really tells me that, within that 1 hour, maybe 3 hour session you have to work with a player, you can make a lot of in-depth analysis about kinematic sequence, but it's very difficult to change that permanent pattern. So most often you're going to get the best, fastest results by understanding the translation information, making a slight adjustment there, and then reprogramming that person, either with exercise programming, coordination drills in the gym, or 15 to 20 minutes of new pattern work a day, and allow it to slowly change that kinematic sequence. So we've actually got Tour Average Golfer in front of us here. So this is a composition of nearly 50 tour pros captured on gears, and one of the great things about this system is just how the great visual representation. So there's a ton of things we can take a look at depending on what we want to see, but the first thing I want us to put on is going to be our pelvis and rib cage sway and thrust. Now, if we go and look at this from the top down view, what it shows us is, where we are at the start, and that start is always our zero measure, okay? Before we start moving, before the club starts moving, that's where we're zeroed out in space. So even if we take a look there, you can imagine that yellow dot would be just as though I swallowed a sensor and it's sitting right in the center of my pelvis. So as we work throughout the course of the golf swing here, let's see how the average tour pro is going to move. There we go. Now this, I think, is something that's really interesting to understand. That pelvis reaches its maximum distance away from the target, or 1.9 inches right there, while the golfer is yet to complete the backswing. That club is still rotating backwards, but watch how the lower body starts to move forwards. See, there it goes, there it goes. So there's a pretty reasonable gap in space there. And we talked earlier about how here at the lab we look at transition sequence first, because that has the most common traits in tour pros. One thing you should understand when we integrate translation is even a stronger percentage of tour pros start a lateral movement left towards the target prior to that rotation occurring. So if we look at how does an elite golfer change direction, the first thing that happens is that pelvis starts to shift to the left. The second thing that happens is that pelvis starts to rotate left, and then the rest of the body follows. I think that's really, really important to know. Now, when we get down here to impact, we can take a look and see that on average, that golfer has got their pelvis 4.9 inches closer to the target than where it was at setup. Remember, we always start off at 0, and we get to impact, we're over here. If you remember from the theory portion, thrust is measured in inches and tells us how much closer to or farther away from the golf ball that particular body segment got. So again, let's take a first look here at the pelvis. We're going to go in, and I think this pelvic thrust or early extension is one of the most common swing faults we see in amateur golfers. And it's something you should always be aware of, because I'd say thrust is inversely correlated to rotation. So what that means is the more thrust we see, the less rotation we see. You could also consider it the enemy of rotation. Now, we take a look at this Tour Pro average, we can see that very quickly they get into negative thrust. They're actually having their pelvis a little bit farther away from the ball than they were at setup. So, top of the backswing, they're just under an inch, 0.7 inches on average. And now I love this, because on the downswing, you can see them further back out a little bit away from the ball. So that pelvis is actually 1 full inch farther back from the ball than it was at impact. So when we look at that, say from down the line, that's what really kind of gives them space. It allows them to rotate. But it also, I think, is important because when we swing that golf club, there's a tremendous amount of centripetal force. That's force down here pulling outward, right? That golf club weighs, pretty close to a pound, right? If we swing that at 100 miles per hour, gosh, that converts to 44 meters per second. We take that, we square the velocity, we divide it by the radius of the golf swing. That's going to be, you know, on that iron, it's probably in the neighborhood of about 60 inches. You know, and then from there, we're going to go ahead and factor that in, divide it by 9.81 per meter squared. So we know the amount of G-force pulling us. Club weighs about a pound. Gosh, that club is pulling us forward north of 150 pounds of force. So we really got to dig in and resist that. And I just don't think most amateur golfers have an appreciation for that. So that thrust can be a great indicator as to whether or not your golfer is winning the tug of war. So definitely something to look for. The next thing I want to talk about is actually going to be lift. So let's hop around here to face on, and we'll start to take a look at lift. So in order for that, I am going to go down in here into my body graphs, and I need to find the lift graph. So you can see the way that Gears has the graph set up. On the left, I can look at sways, and this is pelvis and rib cage sway. Then I can look at thrust, pelvis and rib cage again, of course. And right now here I've got lift. So again, this is measured in inches. How much up or down did that particular body segment go from where it was oriented at address? And if we take a look here, we see just a little bit of negative lift or a little bit of drop as we get towards the top of the backswing. And as we look here, this is something we see people talking about quite a bit as it pertains to power. So we're going to move us right here. That puts us right at the top of the backswing. Now, what we're going to be able to see, let's pop in our wireframe here, is we're going to see more of that negative lift. We're going to see the upper and the lower body drop down closer to the ground. There we go. So as I pull my graphs back up, I can see here that at this point in time, I am about right there. I'm about 1.3 inches lower with the pelvis than where I started, and about 1.6 inches lower with the rib cage. And you know, this position here with lead arm parallel, we're going to come back to that because that's a key point in time that I think that we should all analyze. From right here, we see how there's a pretty rapid acceleration of lifting, of moving up through to impact. So this is kind of like that power squat through transition, and then that huge amount of vertical thrust. And I'm gonna refer back to this P5 position in a second. But if we look, we went right from here to impact where we've raised over an inch. But what I want to show first is going to be how this looks with the driver. So now we're in that same spot. Okay, we've got 1 inch drop, right? But now when we get that ball up on the tee and it becomes more about maximum distance than maximum distance control, we get to impact, we see the pelvis and the rib cage are both higher than when they started. So how do players do this? Well, again, I'm going to come back to this position because, you know, if you refer to our ground force module, one of the things that we got from Dr. Scott Lynn is how we see maximum vertical force at that same moment in time. And so what do we need to do, or what do we see the best players do in order to be able to execute that? Well, when we get to the top of the backswing, we see more sway off the ball from upper body than from lower body. But I think this next thing we see is really kind of contrary to what a lot of golf coaches think happens, and certainly a lot of golfers. So watch this. Watch how that center rib cage actually gets in front of center pelvis here at P5. So I see maximum negative lift, and I see upper body sway in front of lower body sway. Why the heck would this happen? Well, you know what? If I'm going to jump as high as I can, you know, get as much vertical force as I can, one of the first things I need to do is I need to drop, right? I need to load those muscles of the quad, of the glutes, you know, maybe even a little bit in the calf. So I need to do that. That's going to give me the opportunity to explode. But if I want those muscles to be able to generate force, there needs to be some mass, some resistance for them to generate force against, right? If I'm trying to push against the air here, I can't generate any force. As soon as there's something to push against, now my chest can generate force. So I believe we see this upper center get forward, kind of, towards over the left foot. So now there's something for this lower body to push up against as we explode up on average over 2 inches in that last portion of the downswing. Now, typically the more powerful player you see is going to have more vertical force. And when we take a look at like world long drive champions, we see those guys going up as much as 5, 6, 7 inches from P5 through to P6. So definitely some important stuff for you to take a look at there. Now let's start to profile a couple more common sway thrust lift patterns that we think are going to be beneficial to you and your players. Now that we've gone through some of the basics of these translations, let's identify a couple key points in time and patterns that will just serve as kind of a useful baseline as you start to pay more attention to this stuff with your students. So, the first thing I've got here, is again just a face-on view of the driver. We can see how both the lower center and the upper center are behind the golf ball, right there. And upper center is also behind lower center. Now, this type of alignment to me is really, kind of how they do it in terms of maintaining stability, but creating that upwards angle of attack to, maximize launch and spin for optimum efficiency. Well, let's see what happens when the ball's on the ground. All right, so now here's our same Tour Pro composite with an iron, and we're gonna wheel it right to impact. So on one hand, we see a very similar pattern, right? We see how lower center is ahead of upper center. And if we go back, top of backswing, we see upper body sway outside of lower. But just like before, we see, there it is, upper gets ahead of lower at P5, so that still happens. And then they still invert on the way down. But when we get to impact, I think this is really important because we see lower center ahead of the golf ball, very important if we're going to strike down, and we see upper center on top of the golf ball. And so that really is a translational position that allows for consistent low point control, which is going to be one of the most important measures for quality strike point on the club face. So I think it's really important that we take a look at a couple of those basic positions, and if your amateurs are not able to achieve those, start to work back through the different chain of events right to set up and see where that pattern starts to break down and understand if I want to improve that transitional or lateral position, do I need to do it through rotation or do I need to do it through translation? Now, let's hop into our next section where we're going to talk about 3D club dynamics and kind of what we see and what we like to see and how it affects ball flight. Now that we've gone through and understand the basics of how a club is calibrated, what a couple of the measurements mean, let's do a little deeper dive. We've got our composite tour professional average up here. So we're going to go through and just, kind of a once over of key metrics that we look at, our thoughts on where some of these things come from, and then we'll compare and show you a couple of the crazy things that you're probably going to see if you start taking a look at this data. So as we look here at setup, one of the first things that I'm going to want to do, I'm actually going to kind of remove the body a little bit here to get just a little clearer view of the club. We can bring that back at any time. Then I am going to go through, I want to put on right here our shaft deflection line, and let's get to a down the line view here, and let's also go with our shaft extension line. So this really kind of gives us an idea of exactly where the shaft is at address if it was a rigid body, and where it would be if it remained rigid, based on this mid-hands portion down to the upper piece of the shaft clip. So let's see, as soon as we start rotating back, even just as early as here, we go face on and we go way in, we already see some shaft deflection. Now, if I take a look here, let's find my deflection graph. So I've got 21 millimeters of positive shaft deflection. That means this leading edge of the club face here will be 21 millimeters in front of where the rigid shaft would be up here at the handle. Again, and this is what's normal. Okay? This is just probably really different. The first time you start looking at it, it seems pretty crazy, but remember, this is an average of over 50 touring professionals. So as we start to go back, you know, we can see we get a little bit more shaft deflection in through this section. And you know, you remember gears is our only system that actually combines club and body. So if I go down here, we can also see, if we compare it to the kinematic sequence, this is when, right in this portion here, we get maximum shaft deflection. That's when we see about the steepest portion of the backswing curve of the club. That's when the club is accelerating the fastest away from the target. So it only makes sense that we would see the most amount of deflection right there. Now let's get our deflection back up, and you know, as we get up here and we're just about ready to change directions, you know, we can see that that shaft, get into our perspective mode here, you know, kind of flat lines, or basically has almost zero deflection forward and backwards. You can see how we have to wing around to get it in here on the right angle. But now all of a sudden, holy smokes, there's a lot going on here and this droop curve that there wasn't before. So let's start to roll our way around and take a look at what that is. All right, so we have a ton of droop right here, right? We've got negative 34 millimeters. That's where it's bending in the toe up position. So again, let's try and get that clear perspective there. At this top of the backswing, we've got 65 millimeters of droop. That's an awful lot of force going through that shaft. You know, and I mean, we can see this on video a little bit, right? We get to that top and we see that shaft start to flex and bow as the player pulls the handle back away from the target. And as we start to work part way down, we're halfway through the downswing, and now we can start to see that that club is actually gone 31 millimeters into a toe down position. So we've gone from 65 millimeters toe up through a really, really fast unloading of the droop, and this is when the golfer starts to pull, exert that normal force on the shaft, causes that droop to start to accelerate rapidly. And as we get all the way down here to impact, we can see how on average these players have 56 millimeters of droop, which interestingly enough, we roll around to the face, helps them deliver it close to a neutral lie angle. So if I look here on my listed club information, right, I've got a lie angle at impact of only 2 degrees toe up when it started about 12.5 degrees toe up. Now let's go back and see what happened on this last portion of the golf swing as it pertains to shaft deflection. Okay, so when we're midway down, we've got, you know, about, what is it, 17 millimeters of deflection it shows there, 14 millimeters. Right, we can see that right there. So that means the shaft is bent 14 millimeters back. And we can just start to see it right there. Not a ton, okay? But what happens now, as the golfer starts to exert, hopefully starts to exert more of a normal, or what I would call kind of like a longitudinal force on the shaft, that'd be something that would maybe feel a little bit like pulling the grip off, if you could imagine that. That causes an inversion in the deflection pattern to where you can see now it's starting to actually bend forward in front of the deflection line. And that's something we see in all of our professional golfers where there is positive deflection at impact. Now, what's happening here is the center of gravity of the club head, which of course, as we know, is set back from the face, is trying to unload and get itself in line with this center of the force application. And that's what causes to go this way. Now, If you see something that's happening the other way or excessive this way, you can start to infer that the golfer is kind of not putting the correct forces on the club. And that could be through poor perception, or it could be just through poor mechanics. So let's go over here, and I'm going to find an example of some of the crazy stuff that you might see. So let's go right there. Let's pop this to impact. Uh-oh, that's not going to work out well. So right here we've got 62 millimeters of shaft deflection, and we've only got 32 millimeters of droop. Okay, so we've got like more than 3 times the deflection this way. That's going to put crazy loft on the face and have that sweet spot moving all over the place. And we also don't have nearly as much droop as we'd want to see, which is going to have that club coming through, I'm going to guess, pretty darn upright. Yeah, it's coming in, gosh, 7 degrees toe up. So why the heck could that be happening? Well, I can tell you in this specific case, it was a lot of this was because the golfer had an incorrect concept as to how to release the club. They thought they were supposed to have kind of a push-pull, like push with the right hand, pull back with the left hand, something I would call like a torque couple release, as opposed to a pulling normal force release. So, for me, that instantly explained this massive, massive deflection, okay? But when we take a look at the droop, and what we'll just share with you what we see in terms of, in terms of what the best players do. But when we look over here at the lie angle, we see lie angle at address, then we see lie angle at impact. And the amount of droop has a high correlation with the delta, or the difference between those two lie angles. So if we see not enough droop, it could be because the player starts with the handle and returns the handle to the same position. Certainly nothing wrong with that. That's actually something we see is pretty common in our tour pros on their iron delivery. And it's very simple when we see that to just adjust the lie angle of the golf club. So here's an example of that low delta with an iron, and how we can make a simple adjustment. So we've got one of our college players right here on the right hand side. Actually, I'm going to get their club back to address right there. And if we look over here to address, it starts 4.8 degrees toe up. This is actually the lowest delta we've measured. When we get down here to impact, it's 1.37 degrees toe up, delta of only 3.5. Incredibly, incredibly low from what we've seen. And that's why there's little to no droop. And in this case, it's great. You just make a simple lie angle adjustment to the clubs, don't change anything, and we're good to go. With the driver, it can be a little bit tricky because drivers are built at such a modern upright lie angle. So you may want to experiment with different length of driver shaft, or just start to cue your golfer to have a little bit more pull, a little bit more normal force, or perhaps start with hands a little bit higher and see if they create the same delta for a resultant more neutral lie angle. It's going to make it a little bit easier to control their golf ball.